Hello and welcome to my presentation. My name is John Sheehan. My contact information is johncSheehan@lewisu.edu. I'd like to take this opportunity to thank Dr. Phillips and the class for what is, in my opinion, a very successful 8 weeks. I came into this class with a very limited knowledge of UAVs and the systems operating behind them. Um, and now I feel as if my knowledge base has grown considerably. And I not only contribute that to the lectures, but I also contribute that to the discussion forums. The variety of topics that were brought in really helped me expand upon my basic knowledge and fueled a desire to learn more. So I'd like to thank everybody for that. And with that being said, let's get started to talk about this article. So initially, when I was researching articles, I wanted to find something that not only was interesting from the get-go, but also would fuel further research in the same topic, but maybe the same country or what else they're doing with UAVs. So when I found this article talking about water sampling from a crater lake in Japan, I was very interested. So I dove into it, started really reading it and doing some research and looking it up. And I looked at the crater lake here and thought to myself, did the Mars rover take this shot? Why is this even significant? Why are scientists wasting their time with trying to predict volcanic movement on something so desolate? And then I came across this video here. As this video shows, excuse me, these crater lakes are tourist attractions, um, not only for adults, but as we saw, children and elderly. And it's the government's responsibility to keep everybody safe. So that makes more sense to me why they are really investing in almost an early warning system to help detect volcanic activity. And the Japanese government was under a lot of criticism in 2018 after this event happened here. Um, one of the volcano erupted by a ski resort, and as we saw in that previous video, the amount of people that were there, excuse me, are also there in the wintertime. The Japanese government was criticized for their slow response time to this incident. According to some reports, it took the government about an hour to start evacuations and notifying the citizens of what happened. So again, this is another reason why the scientists are out trying to predict any type of volcanic movement to potentially save lives. Speaking of volcanic movement, this is a volcano bomb, or volcanic bomb, I'm sorry. The lava, once it hits the air, is still superheated, but the outer crust cools, as we see in the picture to our right. In 2018, I don't know if you recall, but off of the Big Island in Hawaii, 23 people were injured on a sightseeing boat from these exact volcanic bombs. Um, there were also some concern in Japan that this would injure the people by these crater lakes. And not to mention Hawaii, but in 1993, 6 people were killed in Colombia from this type of eruption as well. So the location of the crater lake is just northwest of Tokyo, as we see in our first picture here to the left. So pretty close proximity if we really think about it. What got my attention about the proximity of the Tokyo and the active volcanoes was the fallout if a volcano erupted with the ash and soot and everything like that. As we've seen recently in the United States, the wildfires out west have affected air quality in Illinois. And that's half a country away, or yeah, half a country away. I can only imagine what would rain down on Tokyo and the other cities if one of these volcanoes erupts and the citizens don't have some type of lead time if there is activity. But the picture marked B, labeled B here in the middle, is a picture of our flight path, which is better depicted in the picture to the right. We have a designated takeoff and landing site marked with an A, the flight route, and the sampling site taken by the drone. And then the U1, if you can see it in the bottom, was also a sample site. So why do it by drone? Well, these crater lakes depict 3 of our 4Ds we learned about in week 1. It's definitely dirty, definitely difficult, and certainly dangerous. I personally wouldn't want to be a scientist in my little rowboat trying to find a spot where I took a sample before, going through a cloudy area with who knows what's in there, and a big field of floating sulfur. I would want to avoid that task if I could. So the UAV is a perfect instrument to come in and take samples from the exact same spots, which they notated in the article. They said using GPS, they can take samples from the exact same spots while dealing with the updrafts created from the water, being that the surface is about 10 to 20 degrees hotter than the ambient air. And the UAV can fight through that and still hit their predetermined locations. Unlike somebody floating out there in a boat or trying to lean over the side to try to take a sample. So would I rather risk a UAV versus a human? Certainly. There's no question about that. And now here's the collection process. If we look at the series of pictures on our left there labeled A through E, we see our 2 scientists And in the middle of the picture is their drone. And then B, you see the drone taking off. And as it takes off, as you see depicted in C and D, the bottle is being towed beneath it. And our final picture, E, you see the distance between the drone and the bottle. They have actually taken several samples with different lengths of line from the drone to the bottle to see, depending on the day and the temperature of the water and the wind. But to our right, we see the bottle itself. So we have a rope connected with a carabiner, and it's pretty simple. You put the collection bottle in the water, right? And the water will flow into the bottom and out of the top. And now when this bottle is lifted out of the water, gravity takes over and the two stoppers fall into place, collecting and saving the water sample. And then the sample is flown straight back to the takeoff and landing area. So here's our sample results of the different samples. This only is two different samples that they took. Just that they posted this as an example. Um, they were doing a lot of trial and errors with this, with the length of the cord, with time of day, with different humidity, rain, as you see. But the samples are right around about the same. And that's what the scientists are looking for. If the if the samples depict changes, that could actually show that there is volcanic action or movement. So part of what I discussed at the beginning of this presentation was an interest in the regulations for Japan. Is it as strict as the United States or other countries? It's actually pretty relaxed. If we look on our right-hand side here, do we need permission to fly a drone to Japan? Really, it's not that bad. You really need, if you fall in the criteria, is the drone way over 200 grand? Is it going over Tokyo, a large city? Is it going around an airport? Specific airspace? Prior approval is necessary, as we see on the bottom as well. The only place that there isn't permission is out in the country. As we can see, it says other airspace. No permission required, which was very interesting to me since a drone was used or attempted to be used to assassinate a government official. And Japan didn't take a knee-jerk reaction of banning every operator and every UAV or registering them. They put forth these regulations. And I believe from just reading, they treat it as an isolated incident. Unlike countries, Israel, for example, where Hamas, ISIS use UAVs as an instrument of war, Israel has reacted by having defense systems. We don't see that in Japan as of yet. Well, at least they don't admit that they're there. I'm sure that they're there, but it's it's easy. You fly over there to Japan and you can bring your UAV. And here are my sources. I'd like to thank everybody for tuning in, and I appreciate any feedback.